all on this fourth day of FTP. I am very happy to announce that today we have with us Mr. Ravikant Tyagi, as you can see on the screen also. He is from Brain Mentors Private Limited. Hope you are enjoying the sessions, which is also evident from the appreciation messages typed by you all in the chat section. I am sure that you will enjoy this session also and all the sessions ahead. And let me now introduce our guest and speaker today, Mr. Ravikant Tyagi. Mr. Ravikant Tyagi is a data scientist and co-founder of Brain Mentors Private Limited. Mr. Ravikant is passionate in providing high-quality technical trainings on data science and big data. He has delivered trainings for various corporate clients like Tata Power, India Mart, UST Global, Clear to Pay, Bechtel, NIIT, HCL, and many more in technologies like Python, R programming, and big data. He has also worked as a data scientist and big data engineer in UTS for more than 2 years in the role of a data scientist. He has trained more than 2,000 students and 100 plus faculties of various reputed universities and institutions so far. With this, may I now request Mr. Ravi to kindly take over and address the audience. Over to you, Mr. Ravi.
Thank you, sir.
Welcome,
So
sir.
a very good afternoon to all of you. And I hope this FDP is going fruitful for all of you. And I will try to give my best to all of you so that you will be able to understand more and more things. The only problem you can say with me is that I'm going to take this session as a totally practical. It will be like 90 to 95% practical based on the coding parts. Okay, so there will be a little bit of theory also, but generally I'm going to focus on the practical part. So I hope you are aware of the agenda that I'm going to share with you all, the topic with you all, that is face mask detection using Python. We all know that it's a high time for COVID-19 and it's again increasing and increasing. So face mask is really mandatory for all of us. And in today's time, there are a lot of applications and examples going on in IT industry that are related to the COVID-19. I have built few case studies that are only related to COVID-19, like I can detect whether you are infected from the COVID-19 or not. So there are various desktop and web applications running on. And in today's session, you will be learning the live open CV face mask detection using Python. There is one more thing I would like to add here. Generally, if you will search on internet, you will find a lot of examples that are related to deep learning only. A lot of people are performing face mask detection using deep learning. I'll be telling you both machine learning and deep learning, because if we talk about deep learning, then we have framework like TensorFlow, Keras, and all. So it become a little bit easy to implement these kind of algorithms. What if we have to implement the same algorithm using machine learning, like SVM we have, logistic regression we have, or any other machine learning techniques? So I'll be showing you both of them. So first, I would like to have a basic introduction from your side, like what exactly your backgrounds are. Are you all aware of some sort of programming like Python we are going to implement with today?
All
Yes,
the
sir.
participants can write down their answer in the chat section.
Yeah, you can simply write down your answers on chat window that you are actually from the background of Python or any other programming like R, MATLAB, any, because I expect like this is the basic thing from you all.
So most of the answers are in yes.
Okay, it means generally people are familiar with Python programming. So it
Yeah,
will be
Python and
a
R.
plus for us that you all are familiar with this thing. Okay, okay. Okay, thanks for the confirmation. Now, how many of you are aware of this OpenCV package for image processing? I hope a lot of people are familiar with this OpenCV package also. It's very popular package in industry.
Your
And
answers
how
are
many
in
of you are
yes.
totally new? Like you are learning these kind of thing first time. Okay, so few people are saying yes and few are saying no. Like there might be a few people that are learning these things first time.
Yeah.
So I will be taking this session from very scratch. Okay, I'll just consider you all as beginner. Okay, why so? I'll tell you the reasons. So first of all, if we talk about if we start with the face mask detection problem, first we have to understand the basics of image processing. And image processing is one of the most used or one of the most popular department or area you can say in IT industry today. In IT industry, in machine learning, in data science, because a lot of example like you see a self-driven car is completely example of image processing. You have humanoids like Sophia, which are again examples of image processing. So image processing is like everywhere. In medical, we have image processing. In every department, you will see examples of image processing. So the most important thing is not about the implementation of machine learning or deep learning algorithm. The most important thing is how you understand the images, how you understand your data. The more you will understand your data, the better you will write your own algorithms. If you are not able to understand your images, your data set, then you won't be able to write down the algorithms as well. So this is a simple strategy. This is a simple philosophy from my side. You just have to understand how images work, how we convert those images into the data that we can use for our purpose, like machine learning, deep learning, and then it could be any kind of images. Okay. So already sir already discussed about me, like who I am, what companies I have worked with, in which colleges and universities I have provided training. So these are the few things that are about me. I have given more than 20, like this 20 is less number. I have given more than 30 40 FDP programs in different universities like MET University. I have been the main resource person in the NI Triple TR Chandigarh also. So these are the different universities where I have delivered trainings on machine learning and deep learning. So the same thing I'll try to deliver to you all today. So first, what we have to do, we have to get start with a very basic of image processing, how we generally do image processing. Okay. In today's time, if I start with the examples, okay, in a lot of applications, in a lot of department, you see there are a lot of examples of image processing. Like if a drone is there, then you can see object detection is continuously going on. Okay, object detection has become very, very common, and I hope you all understand this thing, that object detection, how common object detection is in today's time. Okay, so whenever we talk about object detection, we are generally talking about any kind of object, whether it could be a person, it could be a car, it could be anything in this world. Okay, next thing about image, except this application, there is a very common example you see in the market that we generally have today, that is the fast lane tag. Okay, so I hope you all have seen this fast lane tag. And this fast lane tag is like, basically what it does is it only detect the car license plate and send the data to the server. One of the example of image processing again. Then in medical, in bio department, a lot of x-ray image classifications, disease classification is going on. Then in self-driven car, obviously we cannot forget this thing. Self-driven car, there is a camera on the top of car and it is continuously detecting and collecting the data of images and continuously performing some operations based on it. Then one of the most popular example that you use daily, that is the face recognition in your mobile phone. You unlock your mobile phone with your face. So these are the basic applications, basic examples of image processing. Okay, now, what are the steps to perform these kind of application if you want to build? What should be your strategy? What are the steps? Like what should be the step one? What is step two? What is step three? How can I get to all these applications? First of all, we need to load images using Python or any other programming. But first, let me tell you one more thing. First, you need images. You need images data. If I'm talking about face mask detection today, then what exactly I need? What sort of data I need? Can anyone give me answers in chat window? If you want to perform face mask detection, then what sort of data you want? What sort of data should I have? Just write down your answers in chat window, whatever you think. So image of face, okay, or let's get it more detail. Yeah, exactly. We need images of faces, but still you need to differentiate one more thing here. Images of face with and without mask. Exactly. So this is the major thing. We need two kind of images, people with wearing a mask and people without wearing a mask. We need two different kind of images data set. Okay, and from where you are going to collect this data. Now let's talk about this question, from where you are going to collect this. Are you going to search on internet or you are going to click the pictures? What sort of strategy you will make for this? Because I will say one thing, On internet, let's say there are 90 type of data sets out of 100, but still 10 type of data set is missing. So how you're going to generate that data? I'm talking about data generation for your own whatever your work is, whatever your requirement is. How you are going to do that? Getting my question, everyone? I'm asking, if I have different kind of data set available on internet, but I do not have all type of data, there will be few time will come like you do not have different kind of data sets available that exactly you need based on your requirement. So that's where you need to perform some sort of algorithm so that it will be able to fetch data for you. Okay, let's take one example. If I want to build one algorithm of celebrity face recognition. Okay, let's understand this thing. I want to build a celebrity face recognition. How you are going to build this algorithm? You need celebrity faces. And let's take an example. Then on internet, you do not have this data. Understand this question carefully. I'm saying I want to build a celebrity face recognition. I want to make sure that this is Salman Khan, this is Shah Rukh Khan, this is Hrithik Roshan, this is Amitabh Bachchan, like this. But on internet, you do not have a lot of images of these particular actors. What you will do then? How you are going to collect the data? Now, any answers? Anyone?
So there are some answers in the chat section like create patterns, augmentation, data imputation, mutation.
Yeah, basically these are the strategies you are telling me, but still the main thing is how you're going to collect the data. You do not have the data. Data imputation, augmentation, it's okay. All these terms are okay. But I'm asking how you are going to collect the data. You do not have even the data. And if you do not have data, how you are going to perform cleaning and all?
There is one more answer, extract data from some source feed data.
Please be more specific, like what exactly you are saying.
Guys, please write your answer in the chat section.
Okay, let me again ask you this question. I want to build a celebrity face recognition algorithm. Whatever the celebrity face in front of you will come, it should recognize which celebrity is this. I'm just asking you that on internet, if I do not have this data available, if there is no data of any celebrity on internet, how you are going to perform it? How you are going to collect the data? From where you will collect this data? There should be some strategy. There should be something that you will be able to do.
Swarnendu, yes, please.
Yes, sir. Sir, we may like to get the data from some other source, scan it, put it back in the computer. Say, like for celebrities, say there are some printed pictures of those celebrities. So we can scan it, put it back, and then start running the model on the same. That could be one of the way of doing it, sir.
Okay, so according to you, sir, we have one strategy, but there is a basic clause about this strategy. Let's say how many of the images you will scan? 10, 20, 100, because for a particular face detection, I just need at least 300, 400 or 500 of images with different angle, different pose.
Yes, sir. Agreed to that. Agreed to that. But that is a start point when you don't have anything. I'm
Yeah,
saying
exactly. There could be this could be the starting point. Like you
exactly.
can have few images with this strategy.
True, sir. True, sir. Thank you so much, sir.
Or any other one would like to share their views about this thing? Okay, so there will be one more strategy that I would like to tell you. What if I give you videos, the interviews or any other video like this time we are having this conversation and continuously you are looking at my face. I'm looking at few of the participants. Continuously you are having the data of my face. If I give you this kind of data, this kind of video, will you be able to extract the face of my using some algorithm or something?
Yes, sir.
Definitely we can get this. Let's say if I give you a movie of Shah Rukh Khan or Salman Khan or Hrithik Roshan or Amitabh Bachchan, anyone, and I'm giving you just a little bit of 1 minute or 2 minute video. in which only the focus is on Amitabh Bachchan for continuously 2 minutes. He is speaking something, he is giving some speech or kind of thing. So I can easily collect the data of his face continuously from the image. He will be having different expressions, different poses, different lightings and all. And I'll be able to get a lot of images from single video. That will be a great source for us to get the data from it. So this is one of the strategy that I generally prefer. So in today's session, I'll be telling you that how to get the data from your own camera. Using camera or video, it's up to you, but I'll be recommending that I'll start the camera and that camera will be able to detect the face. And from that particular frame, it will collect your data of face with and without mask. Okay. So after loading your images in Python or any other programming, what will be the second step? We have to convert those images into array. So is there anyone who would like to explain this point? Convert images into array. Why? Is it necessary to convert our images into array?
We have received one answer, that is yes. For
Okay.
computational purpose.
Or any other answers?
Anybody else who would like to answer this question?
Is it necessary to convert our images into array?
Need numeric value is another answer, sir.
Need numerical value to have computational data. Okay. Let me tell you very basic thing. For matrix computation, actually images are already in form of arrays. Yeah, exactly. Images are already in form of array. If you pay attention to images very closely, they are actually array. Collection of some red, green and blue color value. They are already contained in a n-dimensional, 3-dimensional array, basically 2-dimensional or 3-dimensional based on the color dimension we have, 2D or 3D. They are already a combination of array. We just have to use our Python or any other programming to get the data and convert them immediately into array. Okay. So we will converting these images into array. I'll tell you reason why and how. And after loading images, we can perform any algorithm because now you have array of numbers. That's it. The only 3 requirement we have all completed. And using OpenCV, we'll be able to perform all these steps. We can easily load the image, convert image into array, and finally we'll be able to apply some algorithm on it using a single package known as OpenCV. Okay. Now, OpenCV, what exactly it is? It's a very basic introduction to OpenCV. Like what exactly it is some sort of a computer vision and machine learning software library, which will help you to detect the faces, to start your camera, collect images and all, and convert those data, those images into array. So OpenCV is going to help us to work with the images basically. So for image processing, we are going to use this particular thing. Second thing, library has more than 2,500 optimized algorithm. So when I talk about OpenCV, it is saying that it has more than 2,500 optimized algorithm with it. Okay. And it has C++, Python, Java, MATLAB interfaces and support Windows, Linux, Android and Mac. Then will help us to load images in Python and convert them into easily array. And finally, each index of array represent red, green and blue color pixel, which range from 0 to 255. That I'll be showing you. Now, the most important thing for us to understand here is how computers see images. Like as a human, you know that this is an image, there is some sort of an object is inside this image. But how a computer see images? Like this. What exactly it is now? You can see there is an image here. You are looking at the person looking in a camera, some sort of thing. But how a computer is going to understand this image? How a computer will see this image? Okay. So it's a combination of some sort of values that we are going to discuss. Getting my point, everyone? How would you differentiate between CV and image processing? I see that driving car is an application of image processing. Yeah, image processing is completely a field of study of images. Okay, so if I'm talking about image processing, it means I'm simply saying that whatever data you have of images, I'm going to process it. It could be anything, whether it is self-driven car or any algorithm or any application it is. Okay, so Open Computer Vision is some sort of a package that we are using here just to perform image processing. Okay. Okay, so do we have any questions still here? Anyone would like to ask anything? So till now, I just told you what exactly we are going to do. We are going to perform some face mask detection using Python and OpenCV. I told you basics of image processing. Now we'll be switching towards some practical approach, like how we are going to do all these things. But before moving, if you have any questions, any queries, then please ask.
The participant is saying that she was asking question difference between computer vision and image processing. How can we differentiate whether the application belongs to image processing field or computer vision field?
Okay.
Yeah.
Okay, so basically, if I talk about like image processing and computer vision, okay, so image processing is simply talking about the processing of your images. And similarly, when we talk about computer vision field, it is also talking about like in your computer, like whatever the images you are feeding to it, how it is going to visualize those images. Understand a simple scenario. As a human, I told you it is some sort of an image you are looking at. Okay, now how my computer is going to visualize this thing, how computer vision is forming this image. Getting a point? This is computer vision and how computer is visualizing that particular image. Okay, image processing is simply the field where we are talking about processing of images.
I hope the question is answered. And there is one more question, sir. Is the procedure same for black and white images and colored ones? Ankur sir, kindly
Sir,
allow
I
me.
did that.
Okay.
Hello.
Yes, sir,
Yes,
you are audible now.
I'm audible. Okay.
Yes,
yes.
audible, sir, audible.
Okay, so is the procedure same for black and white images and colored ones? Yeah, procedure is same. There will be some sort of methods available for you, and using those methods you can convert either you want black and white images or you want some colored. By default, let's say you have colored images. In your programming, you will have the option to convert them into black and white. Okay, depends on you whether you want colored images or black and white images.
Yeah. I think you can go ahead, Mr. Ravi, now with your presentation, and we can take questions after some time or at the end of the session now.
Yeah, okay, sure.
Yeah.
Kanika ma'am, I'll get back to you. Okay, definitely I'll get back to you what exactly you want. I understand now. You just want to understand the difference between this computer vision thing, application of it, and the image processing. Okay, so next we have, okay, so how we are going to get started with this thing. So to get started with this OpenCV, what we have to do, we just have to install OpenCV Python in our machine.
I can.
Yeah, please go ahead, sir. Please go ahead.
Yeah. Okay. So you all, I hope you all are familiar with this Jupyter notebooks. Everyone familiar with these Jupyter notebooks or not? Is there anyone who is not familiar with Jupyter notebooks, Anaconda Navigator and all?
I think most of them are already familiar with these things, sir. Yeah. Answers are in yes.
Yeah, I'll be sharing all the files. You do not have to worry about any file. I'll be sharing all the files that we are going to code today. Okay. All right. So first of all, let's create a directory here. So basically, first what we have to do here is we have to install the OpenCV. You can simply write here exclamation mark pip install OpenCV hyphen Python. Okay, this is the simple command that you need to execute, and you will be ready with OpenCV in your Jupyter Labs, in your Jupyter Notebook Anaconda Navigator. Okay, this is a simple command. You do not have to install OpenCV from any other platform. Just go to your Jupyter Notebook and execute this command. Simple. So I hope it is clear to all. After this, we are ready to perform the image processing. We just have to import CV2 package. So the name of the package is CV2. After installing OpenCV Python, you have to import CV2. And now you can directly use a method known as IAMRead. So IAMRead is a predefined method inside CV2, which will allow you to read the images. Okay, now let's take one example, one more example. Is it really necessary to use OpenCV to load the images? Can I directly open images using Python? I'm asking, is it really necessary to use OpenCV? Why can't we just simply open the file like this? So suppose if I say that we have an image, let's say this is the image, okay, and I'm going to read this image. We have to read this image, and all I'm saying that I'll use simple Python. So I will write image1.jpg. Now, what will happen now? Any idea, anyone? If I use, okay, I understand your answer that you are saying will not be used OpenCV for this particular all the operation. But still I'm saying if I open my image like this, then what will happen? Will it give you some array or not? What is inside this file variable? If I use file.read, what data you will have now? Yeah, we know that OpenCV will convert it to array. Okay, we are aware what OpenCV will do. But I am saying if I am not using OpenCV, then what will happen? If we are not using OpenCV, then what will happen? So basically, it is simply file handling you are writing. Okay, it's a simple code of Python file handling. You are just opening some sort of a file in a binary mode. Okay, so it is not aware. Python is not aware that it's an image. It doesn't matter whether it is an image or something. You just have written the name of a file with read binary mode. So it is going to return some binary data to you. That's it. So if you will check the type of your data, it will return you some bytes because it is already converted into binary type. So you have a bytes type of data. And if you have a bytes type of data, then obviously you cannot directly convert this into array and it will give you some RGB color values and all. Getting my point, everyone? So that's why we have to use some sort of a package that will allow you to convert your images into array directly. Okay. So I'm going to delete these rows and we are going to use cv2.imread now. So we'll simply use cv2.imread, name of the image. That's it. Okay, now we have this image. And if I check the shape of my image, now it is giving you 400 by 640 by 3. Let's check the dimension of the image. It is 640 by 400. So actually it is giving width by height. Width is 640, height is 400. In our case, it is giving 400, which is the number of rows, which means the column according to the image. Then 640 is the like number of columns, which is the width, and 3 is your color channel. Okay. To understand your images very carefully and very clearly, you just have to do one thing. I'm opening this image in Photoshop. Okay. And let's check what is available at the 0th index of your image. Okay. So what is this now? What these values are? I'm checking at the 0th index. It is saying that this is some sort of values we have. What these values are? These are RGB values, exactly. So it is returning you some sort of RGB values. But let me make very clearly here. OpenCV returns BGR. Okay, so instead of RGB, it returns BGR, that is blue, green, red. Okay, this is the only difference you have to remember. Now I have opened this image in Photoshop as well. And if I go to this image and let's zoom in to this image, you will be able to see a grid. It's actually the array. Okay, so I hope you are able to see this array here. So this is the actual array that it returns. And at each pixel, there is a RGB, red, green, and blue color value you have. So let's check the color value of first pixel. So if I click on this first pixel, it will show you the value is, so I hope you are able to see 133, 145, 161. So let's see 161, 145, 133. So instead of RGB, it is just giving you BGR. So now at each pixel, it is giving you some sort of values like this. Okay. So I hope you are getting the things that how images are working here. What actually you have in your data variable now, in your image variable, what exactly you have now. All right. So I hope it's clear till here. Anyone would like to ask anything? Till here, any questions? Everyone, please give me a confirmation till here if you are clear.
Yes, sir. People are saying it's clear.
Okay. So now we know that OpenCV is returning some sort of array with color values in form of BGR. How we are going to visualize this image? Okay, how we are going to visualize this image means like there should be some sort of method that will open this image. So we have cv2.imshow, and in this imshow you have to pass image, and then it will be able to open this image in a new window. But the problem is, if I execute this code, there are two parameters we have to pass. First is the name of your window. Let's say I have written here result, and second parameter is the image. So if I execute this code, then it opens a window and it immediately says not responding. So I hope you are able to see that it is saying not responding. And why it is showing you not responding now? The problem is that whenever we execute cv2.imshow, it actually wants that there should be some sort of a loop going on in the background that will help you to continuously show the image. And now if it hangs, then you have to restart your kernel. You have to restart this notebook. Okay, let me tell you the problem again. Basically, whenever I run cv2.iamshow, so it wants you to continuously open a window. But if I execute this code, it get terminated immediately. Getting my point, everyone? It terminates that window immediately. So it is not able to show the image to you. So we have to put this thing in a loop. So I will put this thing in a loop here that will be able to show you this image continuously. But when this loop will break, we also have to mention a condition, like I'm writing here cv2 dot wait key. There is a method wait key that I'll tell you is double equals to 27. So I need to break the loop, and cv2 dot destroy all windows. So whatever the window will open, it is going to close it immediately. Now, first I will execute it, then I'll explain it. So let's see the output. Okay, so we have simply opened this image now like this. If you press escape, only if you will press escape, then this window will close. If you'll try to close from here, no, it will not get closed. It will be closed only if you press escape. Why? Because 27 is the ASCII number of escape. Okay, so I have written cv2 dot wait key 2. We just have to understand what exactly this is. And then there is 27. I told you what 27 is. It is the ASCII number of escape. So what is this wait key? To understand this wait key, I'm opening a short document here. Just read it out. Okay, I just want you all to read this paragraph and then tell me whether you are clear with this method or not. Just tell me after reading this thing. Simply 4 to 5 lines you have to read. So if you are done with the reading, just let me know in the chat window.
People are saying done, sir.
Okay, so now if it is saying that if you are saying done, now do you understand what it is saying? How many of you are able to understand what exactly it is saying here, like what wait key is doing? Are you able to understand this thing? It is simply saying that OS has the minimum time between switching threads. Like if you will see in your task manager, there are a lot of processes are going on. Okay, in your task manager, there are a lot of processes, applications are running continuously in the background. So it is saying OS has a minimum time between switching threads. Threads are the sub process. The sub process means some sort of thread is running in every application. So it has a minimum time to switch between one thread to another. So the function will not wait exactly delay millisecond. It will wait at least delay. So 2 is the delay in milliseconds. So it is saying it will wait at least 2 milliseconds, depending on what else is running on your computer at that time. In my background process, how many processes are running or what exact things are running there. So it returns the code of the pressed key or -1 if no key was pressed. So until you press any key, it will continue. It will continuously showing you that window. The moment you will press escape, it will immediately exit that particular window. And from the last line, it will destroy the window that you have opened. Okay. Is that clear, everyone? Is that clear? Give me a confirmation, everyone. What exactly we did here to show the image.
Yes, sir, we can go ahead.
Okay. Now, after displaying the image like this, we'll do one thing. Okay. This time I will use cv2 dot video capture. It is going to start the camera. So CV2.video capture will start the camera. And if I write 0 here, my default camera will be open to you. And we again have to write this code, paste it here. There is only one line we have to write here. Cap.read. And in return, it will give you two things. One is a flag and one is the image. Okay. So first of all, we have CV2.video capture 0. 0 means the default camera of your system. Then we have return cap.read. It is going to read the video frame by frame, image by image. So if you agree with this point, like let me tell you one point, just tell me whether you are agree with this thing or not. I will say there is no such thing like videos. There is just a collection of images. Agree with this thing or not? There is no video. We just have the collection of images that executes frame per second. So it look like a video to you. Agree? So if I write cap.read, what it will do? The camera is already started. It will just do one thing, just read frame by frame, image by image, and will return you image in this image variable. And what is this flag variable? Flag variable will continuously return you true or false. Like if your camera is not working, your camera driver is not available, some error related to camera, flag variable will contain false. So I will write if flag. It means if my camera is working properly, then show the image. Else I will write camera is not working. So I will simply write camera is not working, camera not found, or there could be any other error related to the camera. Okay. Now I have already turned my camera on with this Zoom meeting. Okay. So now let's try to run this program. So it has opened this window. But you will see that it's not actually showing the images. It's not actually showing you the image actually. So I have to write down, let's say I have written 1 here because the 0 is my default camera, and that default camera, over the default camera, I have some sort of a like it is hidden actually. That's why. Let's write 1 because I have 2 cameras. Now the moment I use 1, now the moment I have written 1, what it is saying, camera is not working. Can anyone tell me why it is saying camera is not working? My camera is working, but you are all able to see because my camera is working, but still it is saying camera is not working. What could be the reason for this? Is there anyone who is able to detect this problem? Exactly, it is being used by the Zoom meeting. Zoom is actually using your camera. So that's why you have to understand this point. You have to understand like your camera is not busy with any other program. Okay, then you will be only able to start this camera. So I will stop the video from the Zoom and then again execute the code. Now this time, let's see. Okay, now you'll be able to see me. This video is appearing not because of Zoom, because of OpenCV now. Because of OpenCV, you are able to see this particular window. This will be closed only if I press escape. Okay, am I clear to everyone? So this was a very, very simple demonstration that how we can simply turn camera on and how we can simply start the camera and all. Okay, you can also do one thing, like if you want to start a video, so you can do one thing, instead of 1, you can simply write the path of the video. Okay, if you want to open a video, there's some sort of video in your machine, instead of this 1, just write the path of that particular video till MP4 or whatever the video extension is. Okay, so I hope it is clear to all of you. Anyone, any queries, any doubts still here? Anything you would like to ask, like any line of code or any concept that we have covered so far?
No query from the participants, I think, sir. Everything was understood.
Can we capture individual frame and keep it in array? Yeah, exactly. We can do this and we'll be doing this. Okay, so I'll be telling you face mask detection. So I'll do one thing. I'll click pictures one by one and save it in my local machine. Okay, so we'll do one thing. We will simply use one line of code, that is cv2.iamWrite. So iamWrite is a method that will help you. So first let me execute the code. Now in this iamWrite, you have to pass two parameters, name of the file, let's say image.jpg, comma, your variable, that is the image. Now if I execute this code, it will start saving the image frame by frame in your machine, but every time you will get only one image. It will the new one will replace the old one image. So you have to take one variable, I is equals to 0. And then simply I will write I plus equals to 1. And here underscore curly brackets dot format, then I. And let's make a folder known as images. Okay, so I will execute this code. Just give me a minute. First, I need to stop the video. Then I have to create a folder, images. In this folder, it will start saving your images. Okay, so I will simply execute this code and let's go to this folder. Now in the background, you can see images are being captured and stored in your machine. Getting a point, everyone? So it is actually collecting the real-time images, live images. It is saving in your machine. So you can see it has collected 368 images in only these few seconds. So it has collected my 368 images in just few seconds. So that's how I'm going to collect the data of my face with mask and without mask. Okay. So I hope it's clear to everyone. So I'm going to delete all these images now. Any query, any question? Can we add a wait time between image capture? Yeah, we can add. There is a package known as time. Using time package, we can insert a sleep method. So sleep method will allow you to put a specific delay after every image. Okay. Clear, everyone? Anyone? Any doubts? Any queries? So this is the very basic example that how we will load the images. Okay. The next thing we have to work with is the face detection part. It should detect the face, and after detecting your face, it should be able to save it or collect it or whatever you want to perform with the face part. So I need to stop this one to start the camera. Okay, so now let's go to the next part, that is about the detection of your face. Now, let me ask you all one question. How many of you know how face detection algorithm work? How many participants are there that they know about face detection algorithm, how it works?
Participants, kindly mention your answer in the chat box.
Anyone from the participants know about face detection algorithm?
Hello.
Hello.
Sir, are you able to hear me?
Yeah, I'm able to hear you.
Sir, just put my name in Google. Simple.
Put your name in Google.
For what, sir?
Just
Mr. Raj?
image detection and all. Dr. Raju Ramakrishna Gondkar.
Like for what, sir?
Just put a name.
Okay.
Raju R. Gondkar.
Okay.
Just put enter.
So
Just click over there and images.
okay.
Very next to this one. All my images are coming. First one is me.
Okay. So what exactly the point is like?
Yeah, we could
I'm
not
able to
understand the
No,
purpose.
very simple, very simple. First one you click.
Okay.
Second one you click.
I click on your the second image.
We should answer. We should answer the question of the speaker right now.
No. It is a very simple question, which is in image processing.
No. I'm asking like if I have to talk about face detection algorithm.
Okay, no problem. These are the two images which are coming on your this one.
But what is the relation between face detection algorithm and these images?
Both are me.
Sir, I think you could not understand the question.
Sir, I'm asking the
Mr.
face
Raju.
detection algorithm.
Face detection. I'm telling about face detection only. I'm both of me only.
No,
Both
sir,
are.
I think you are not able to understand the question exactly.
Okay. Go ahead. No problem.
So basically, what you will see whenever you start your camera start and it makes a rectangle on your face. That's how it is detecting your face, na?
Yeah, Mr. Ravi, you
Yes, sir,
please
you
go
can
ahead.
continue,
I
I
think,
think.
yeah, he could not understand the question, I think.
Okay, so basically, if I talk about face detection algorithm, whenever you want to learn about this algorithm, do not search on internet face detection algorithm. Instead of this, search for Voila-Jones algorithm. So anyone heard of this algorithm, Voila-Jones? Is there anyone who have heard about this algorithm, Voila-Jones algorithm? No one? Okay. So basically, whenever we talk about face detection algorithm, it's actually Voila-Jones algorithm because Voila and Jones, these are the two people, Paul Voila and Michael Jones, who introduced the face detection algorithm first time in 2001. In 2001, face detection algorithm was actually introduced by these two people, Paul Voila and Michael Jones. Okay. Now, whatever the features or whatever the code of face detection algorithm is, it is only of 5 to 6 line of code is only there to detect the face from the image. But what exactly goes behind that particular algorithm, how it is able to detect face so easily, that is the important thing they told us, the Voila and the Jones. Okay, so whenever you want to learn about face detection algorithm, just search Voila-Jones algorithm. You will get the exact working of this algorithm, how face detection is performed. I'll tell you few of the parts of it. Okay, so you can see is an object detection framework which was proposed in 2001 by Paul Voila and Michael Jones. And then although it can be trained to detect a variety of object of classes and all. So these are the most important stages of any face detection algorithm. Hair feature selection, creating an integral image, AdaBoost training, and cascading classifier. So whenever you want to perform a face detection algorithm, these are the 4 stages of face detection. Hair feature selection, creating an integral image, AdaBoost training, and cascading classifier. What is hair feature selection? Now I will say you might have looked somewhere around about this hair feature selection part on internet or any other website. If you are learning about image processing and all, then you might have looked at these kind of things. So if I search for hair features, have you seen these kind of images? Have you seen these kind of features, hair features? So now you see, you might have seen these features, or you might have aware of these features, what are hair features, but you're not aware of Paul Voila-Jones algorithm. So now understand this gap. So Voila-Jones is the main algorithm which gives under which these things comes. So first of all, they tells you the hair feature detection, which is actually they have created few hair features. So these rectangle boxes you are looking at here right now, these are known as the hair feature, which basically says that on every human face there is a same combination of colors. Like if I simply take the example of nose, so it says the center part, the bridge section of the nose is bright if I compare it with the left and right, which is the darker part. Similarly with eyebrows are dark if I compare with the upper part of the eyebrow, which is light in color. Getting my point, everyone? So first they detected this hair feature things. They created some hair cascade features for every part of the face, for eyes, nose, lips, and all. So they created different kind of feature. Now if I go to this image that I have opened here, the same thing you will be able to understand in these two faces. So we have these two faces. I'm going to convert this image into grayscale. Okay, now after converting this image into a grayscale, and let's go to this part. If I look at the nose of this person, you will see this part is more brighter if I compare it with the left and right one. Are you able to see this thing? If I make a rectangle over here, so I am saying, now look at this part. This is more bright than the left and right one. Okay, getting a point, everyone? Similarly, if I go to any of the human face, this is a very, very common thing. So these kind of features, Voila and Jones detected first. And after detection of these features, they was able to get some sort of algorithm with them. But the problem is they used a basic maths. So let me tell you what exactly the math they used here. There is a formula written over here is summation of pixels in black area minus summation of pixels in white area. Now this is the problem with this hair features part. It says pixels in black area, do the sum of it. And then pixels in white area, again do the sum of it. How complicated or how time consuming it will become on every image. Just imagine this thing. Because what it is going to do? It is going to take a sliding window. What sliding window will do? It will check in every window that whether in this window face exists or not, hair feature matches or not. In every window it will check all over the image like this, all over the image. So it will, there is only possibility that it is going to make some of the points available only here, but it is going to check in all the parts of the image like this. Okay, so what will the problem? Problem will be time complexity if it will continuously do the maths here. Getting my point, everyone? If it will continuously do the summation of sum of pixels in black area minus sum of pixels in white area, then just imagine how time consuming it will become for you. Okay, so that's why they introduced the second part of this algorithm, creating an integral image. Okay, now what is this integral image? Anyone, any idea from the participants about this integral image? Anyone heard about this thing? Integral image, what is it? What it is?
No answers received, sir.
Okay, simply you can answer yes or no, that you are aware of this integral image or not. Okay. Let me tell you what exactly integral image is. So they introduced this hair features. Now you know what exactly hair features are. Those black and white features, put it on the faces, and then they check whether the summation of black and pixel in white pixel, if I apply this formula, they check value is close to 0 or 1. If it is close to 1, then it means there is a feature of your face. If it is close to 0, it means no feature of your face is available. But this was very time consuming. That's why they introduced the second part of the algorithm of integral image. Now, what is this integral image? So I'll tell you this integral image. So this is the image here. The first you are looking at this image. This is an image, and then it will be converted into some integral part. What exactly this integral image will do and how it is created. Okay. So let's see the example of it. So first of all, it has 31. So we will simply write 31. It has 32. We will write 33. It has 4. Then you will write 37. Then it has 33. Then you will write 70. Then it has 5. It will become 75. Then it has 36. Then it will become something 111. Getting a point? What I'm doing here? I'm just doing the sum. 31 plus 2 plus 4 plus 33 plus 5 plus 33, 36. It will create the first row. If I talk about this column, 31, then you have to plus 12. So it will become 43. Then 31 plus 2 plus 26 plus 12. So you will get a value over here. So you will be able to see that in this image, so they have written here 71, which is actually the sum of 31 plus 2 plus 26 plus this, then plus 9 plus 4. Just add and it will become 84. Then it will become 127, doing the sum of all these. Then instead of this 29, it will become 161. If I do the sum of all these, then 25, then it will become 222. Getting a point, everyone? How it is doing this, how it is creating this integral image. So if I take any number, so I am saying if I take this 22, okay, what will be the value of integral image? Instead of this 22, it is saying 200. Why? Because it is doing the sum of all these value. Just add all these value, it will become 200. What is the benefit of creating this kind of integral image? So first of all, tell me, is this clear that how integral image is created? Everyone, is that clear to you? That this is the original image and this is the integral image we have. Is this clear to you all? After creating integral image, let's see the benefit of it. According to this Viola-Jones algorithm, you have to do one thing. That is, you have to do the sum of pixels in black area minus pixels in white area. There is some sort of summation you have to do. So what it does here is, it is taking a box, this one, 15, 16, 14, 11, 27, and 28. It is taking this box, this purple box. And if I do the sum of this box only, so the value is 111, 111. So it means after adding if I add 15 plus 16 plus 14 plus 28 plus 27 plus 11, then answer is 111. Okay, you have to add 6 values to get 111. What is the benefit of using integral image? Let me show it to you. The box was here. Just look at this box carefully. This is the box of which it is doing the sum. Okay, it is doing the sum of this box in above image. But in integral image, what it is going to do, it is going to take first this 101. So it will simply write 101, then subtract, then add 450 diagonal values. So first it will take the value that is at the top left, then do the add with 450, then go upwards, top right, do the subtract, and then subtract 186. You will get 111 again. Is there anyone who is able to understand the benefit of using integral image? Like if I add 6 values, then I'm getting, if I add these 6 values, then I'm getting 111. Instead of this, if I use this technique, still I'm getting 111. Is there any benefit of using this part instead of the first one? Is there anyone who is able to understand? Like if I use this first, or should I use this second? Exactly, it will use less computing resources because it need only 4 values. It only needs 4 values to reach the same output that 6 values was reaching. Similarly, if I go to some other pixel, if you will go to a larger box, which will have, let's say 20 or 30 values, because in real time, you will not have only 6 value, you will have 100 of values in a box. If you have hundreds of value in a box, you just have to select only those 4 values. How we are selecting these 4 values? These 4 values, the same criteria. First, pick the top left, add with the bottom right, then subtract the top right and subtract the bottom left. The same criteria you have to follow in all the boxes. Just pick only these 4 boxes. Okay, let me show it to you again. If you have any kind of box, so suppose this was the box, what we have to do, we just have to pick, first of all, this 101, the top, the box, the value that is outside the box at the top left, then pick 450, do the addition, that is inside the box, then minus 254, that is outside the box at the top right, and then minus 186, that is again outside the box. And just do the addition and subtraction, you will get the same answer. Is that clear to all? Integral image part is clear to all? Give me a confirmation, everyone. What about rest of the participants? I'm having answers from 5 to 10 participants. And what about others? Just give me a confirmation if it is clear to you, or if you have any doubt, then we'll discuss the doubts then. Okay, so now we have covered 2 major parts of the algorithm. One is hair feature selection and one is creating an integral image. Now the third part is AdaBoost training. This is the complex and important part here, AdaBoost, which is known as adaptive boosting. So do you know what is AdaBoost? Where it is used? AdaBoost? Anyone? Any criteria or dimension for selecting the box? The same strategy. Just pick only those 4 values. Only this is the strategy. Just pick only those 4 values. It will get to you the same answer. Okay. This is the basic strategy that you have to follow. It will give you the same answer, the same conclusion. Okay, so I was asking about AdaBoost. Anyone heard about this AdaBoost or not? You might have heard about this AdaBoost, obviously. It's kind of an ensemble technique we use in decision tree. So we are not going to learn about AdaBoost today because AdaBoost is different algorithm. So there is an algorithm applied at this moment. Yeah, exactly. It is used to boost the performance. So it is used in generally decision trees to boost your trees, which learn sequentially from the weak tree to make a strong tree. That's kind of a technique used. And then finally it creates a cascading classifier. Now the thing is, it's already been implemented. The algorithm is being completely implemented already. What you have to do if you want to implement a phase detection algorithm, you just need a data of hair cascade. So you just have to search on internet hair cascade and it will redirect you to this GitHub link. I'm going to share this link with all of you in chat window. Okay. Now from here, you will see a lot of hair cascade files. These files will allow you to detect the eyes, frontal human face, left eye, license plate. These kind of things you can easily detect from the images. So what we have to detect? We have to detect the faces. Okay. So we have to detect the faces, and to detect the faces, we have to use CV2 and we need to download this file actually. So I have already downloaded this file. I'm directly going to use this one. So we need this file. So the file name you will see is hair cascade frontal face default.xml. Okay, so which file you have to pick? You have to pick hair cascade frontal face default.xml. This is the file. Click on this file simply. You have to download the data of this file only. So it will be able to detect the faces from the images. So I will show it to you how it is going to detect, what algorithm you have to write. So let's, I'm just going to copy this file from my machine. Okay, this is the file. Now we just have to write cv2.cascade classifier, and we can directly write the name of the file. So I have renamed my file to data. So it is data.xml, which will give you hair data. It's an XML file which contains a lot of things that are related to a human face. So using this single file, we can easily detect the face from any image. If the human face is available in that particular file, we can easily detect the human faces from the image. So just copy this code now. I'm going to copy only this code. So I'm going to detect the face from the camera directly. We are not going to save this one. So remove this code. So now to detect the face, what we have to write? We just have to write only cv2 dot. Instead of this, I will write hair data dot detect multiscale. So there is a predefined method known as detect multiscale. In this function, we just have to pass the image, and in return, it will give you faces. Okay. So first I will print faces. First, I will show you what exactly the value of faces is. Basically, it will return you X, Y, width, and height of the face in the image, in that particular image. Okay, so I will tell you what it is going to return. So let's make a window here, and I will name it as yeah, thank you, sir. So basically, I was telling you, if this is the image here, and there is some sort of human beings in the images. So how your algorithm is going to work? Basically, if I run my algorithm, it will return me four things. If it is able to detect the face, there is a face available here, there is a face here, and there is a face here. So what my algorithm will return? It will return you the X, Y, width and height of this face. It will return you X, Y, width, height of this face. And similarly, X, Y, width and height of this face. Are you able to get this thing, everyone? X, Y, width, height, it will return you. Everyone, clear? Any question, any doubt, anything you would like to ask? So if I'm going to execute this code, it will show you X, Y, width and height in form of array. Okay, so I need to stop the video here. So let's execute this one. Now you can see at the back, it is showing you 4 things. And I hope you know what these 4 values are: X, Y, width, height, X, Y, width, height, X, Y, width, height. From this image, it is detecting the X position, the Y position, the width, and the height. Okay. So what we will do, I'm going to create a rectangle in this region. So I will fetch for X, comma, Y, comma, width, comma, height in faces. I'm fetching the X, Y, width, height from the faces array and draw a rectangle on my face. Okay, draw a rectangle on my face. I will write, I have to draw the rectangle on this image. What are the different parameters we have to pass? We have to pass the XY, then the width and height of your rectangle, X plus W, comma, Y plus height. Then the color of the borders in BGR. So the range of red, green, and blue is from 0 to 255. So I hope everyone know this range. The color range of any image of any colors we have in RGB is 0 to 255. So if I give 255, 0, 0, so it is blue, green, red. So the value of blue is 255, green and red is 0. So the color will be blue. If I mix green with it, it will make some other color. And then the thickness of the border. Okay. So I will write all the parameters here. First parameter is the image. Second parameter is the X and Y. Third parameter is the width and height. Fourth parameter is BGR. And last parameter is the border thickness. These are the parameters we have to pass. Finally, you will be able to see a rectangle on my face. Is that clear, everyone? Give me a confirmation if it is clear to all of you, and if you have any doubt, any queries, then you can ask. So that's how we can simply detect the faces from the images. So we are just using 5 to 6 line of code for this particular thing, and it is able to detect the face. But the main algorithm that goes behind this thing, you have already seen that I told you about Euler-Jones algorithm. So it has become very easy for us to detect the faces, but it's very difficult for them. But they made this thing easy for us. Okay, we just have to utilize this thing now. So finally, we have the face detection with us now. Now what I'm going to do is, I have to collect the data of myself with mask and without mask. Okay, this is the important part that is going to cover now. I'm going to take a variable. A lot of people will be interested in this part because I'll show you how to collect data from the videos. So let's take a variable data. And I just want to store the data of face only. Can we try this to detect moving object? Yeah, we can do this thing with the moving object. Actually, I have made algorithm of tracking objects also. Okay, so at the end, I will show you the algorithm that it will be able to track the objects if it is moving or not moving. Okay, Sunil sir. At the end, I will show it to you. So at the end, you can ask me what sort of algorithms you just want to look at. So I'll be showing you a few of the algorithms. So we have this cv2.rectangle, which is creating a rectangle. What we want here is to collect the data of my face only. So I will write image square bracket. Before writing this code, there is a question that I would like to ask to you all. You all are familiar with this NumPy slicing array and all? Are you guys familiar with NumPy slicing? How to slice the 2D or 3-dimension data from a NumPy array? Are you guys familiar with this? Everyone, please give me a confirmation. If you are not familiar, then I will tell you. And if you are familiar, then we can move forward. So that's why I need a confirmation from everyone. Okay. So few of the people are not aware. So let's have a quick recap. So let's say this is the NumPy and I'm creating array here. And the array will be of 2 dimension. Okay, so let's say this is the array I have created. and this array has a dimension of 2. I would like to have slicing in this. If I write x0, it will give you 0th row. If I write x0, it will give you 0th row. I want the first 0th column, 391. Then what should I write? Please give me answers. Anyone? I want 391. I want first column. What should I write here? Anyone from the participants would like to answer? X square bracket colon comma 1. So instead of 1, we can write 0 because we want the 0th column. So now you can see it is giving 391. So what is the criteria here? The criteria here is first you write row, then you write column. Okay, this is the simple syntax. So if I write 0 colon 3, it means it will give you 0, 1 and second row. If I write 0 colon 2, it will give you 0 and first row. Then I will write comma to slice the columns 0 colon 3. So 0, 1 and 2 column will be returned to you. Okay, so I hope you are getting this thing that what we have written 0 colon 2 will return you first and second row, but you have written 0 colon 3. It means 0, 1 and 2. Only first 3 columns will be returned to you. And what if I write colon comma 0 colon 3? Now what will be the output of this line? If I simply write colon without any number, it means all the rows. Okay, it means all the rows. I can also write 0 colon 2 comma colon. It means all the columns. 2 rows, but all the columns. Okay, everyone in the participants, clear to you? This is the basic slicing we do in NumPy. So we have to do the slicing as well here. So now first let me tell you what exactly we need to do. In this particular image, you have X, Y, width, height. Okay, so from this image is of, let's say 400 by 400, but I only need this part. Okay, from the array, I just need this part, X, Y, width, height you have. So you have to slice the array. You just have to fetch this portion only. So I'm going to write here inside the image variable, I will write here y colon y plus h comma x colon x plus w comma colon. This is the face. Now just look at this line very carefully. What I have written here is, so I have written image, go inside the image, go to the y colon y plus h. It means I will first go to this point, this y, and fetch the data till y plus h. It means still here. Then go to x. X is also here, and fetch the data till w. This is w, this is h. And here we have x comma y. Are you getting my point, everyone? What we have written at that particular portion to fetch the face from this image. Similarly, x plus w will return you this. Y plus height will return you this. Okay. Everyone clear? So that's how it will slice the face from the image. Now we have the face. This was the one of the most important part. Now the final thing we are going to write here, if length of face is less than, if length of data is less than 400, then data dot append face. Basically, I want to store 400 faces. And I will write a condition here, or length of data has reached to 400, then break the algorithm. Now, what this particular code is going to do, if I execute this code, it will slice the face from the image and store 400 faces. And after collecting 400 faces, it will break the loop. Simple. So now let's execute the code. So it starts collecting the face. Now it is collecting, keep on collecting. And the time it will collect 400 faces of me. And this is without mask. Okay. The data it is collecting is of without the mask now. and it will quit the window immediately after collecting my faces. So we have to just wait for a few seconds. Till then, you can ask if you have any queries or any doubts till here. Anyone, any questions till now? Anything you would like to ask? So it is still collecting the faces. As there are multiple faces, then if there are multiple faces, then it will collect the data of all the faces. No issue. It will collect the faces one by one from the images. Okay, now you can see it is closed here. So it might have collected 400 faces. So we'll be importing NumPy and do one thing for cross-check part. So I will convert my list into array. So the list is data. So pass this data to here, convert this into array. And now let's check the shape of your data, that is 400. It means you have 400 faces, but there is an issue with this code. There is a issue with this code. How to calculate width and height of the face? So actually I have written this code. It is calculating the height and width here. Okay. We are just provided the W and H already with us. When I printed the faces, you remember it was printing the X, Y, width, height of the face. So we do not have to even calculate that. It is returning by default the width and height of the face. Okay. It is returning by itself. We are not calculating. Okay, so I would like to show you one problem in this code, that we have 400 faces. At 0th index, the shape, the dimension of the face is 288 by 288 by 3. Then what is the index of the first face? The data at the first index. It is changed. It is different. It is 286. Will it be a problem for us if I have the different shape of all the images? Will it be a problem for us if I have different dimension of all the faces? What do you think? Everyone, tell me this thing. According to you, like if you have this kind of data or any kind of data you have, but the dimensions you have are different. And I'm not talking about normalization, basically. I'm talking about dimensions only. At each index, you have different dimension. Will it be a problem or not? Or anyone else? Any other answers? So what will be the problem? Basically, there will definitely be a problem, because whenever you apply some machine learning or deep learning, the data must be of equal dimension. It should not be like some images of different dimension and some images are of different dimension. All the images must be of the same dimension. So that's why whenever we collect the data of the images, we always make sure that the shape of all the images are same. So I will write face is equals to cv dot resize the face into, now you can set the dimension according to you. So suppose I'm setting 50 by 50 dimension for all the images. So whatever the face data it will collect. And also I'm going to print the length of data so that we'll be aware of how many faces it has collected till now. Okay. So I have resized all the images to 50 by 50 dimension. Now my data will become 400 by 50 by 50 by 3. So that will be a perfect dimension for us to work with. So now it has started detecting the face, collecting the data. And at the left side, you can see how many images it has collected so far. Okay, so it is collecting. It will get slow because I am running a lot of processes in the background. Zoom is going on, so it is collecting faces slowly and slowly. Okay, so anyone, any doubts still here? It is continuously clicking the faces, storing them in list data, and then we will convert that data. I will in fact do one thing. We will save the particular variable in our local machine. Okay, so that data will be permanently stored in your machine. So you do not have to collect that data again and again. I will store this face data in my local machine in a single file. All the faces will be stored in a single file. Okay, so it has collected around 300 images. So we have set the number of images to 400. Yes, we can use this algorithm for the leaves as well. In fact, I have performed a disease detection kind of problem. And I will recommend you for the image segmentation instead of simply detection. Let's say the algorithm I'm talking about is some sort of a PhD project of some other faculty. They are working on plant leaf disease detection and segmentation. So I have written an algorithm for them, and they are able to detect the particular portion as well as they're able to segment that particular part. Okay. Yeah, I guess recordings will be available from the, I guess, sir will answer this thing.
So it's already live on YouTube. I have answered this query to the
Okay. Thank you, sir.
participant.
Okay, if I want to collect about 7K images, so it will work. Yeah, it will definitely work, but it will take a lot of time it will take. Okay, but it will collect the data easily. You can see I have collected 400 images, and to collect the 7,000 images, what I have to do? Nothing. I just have to write here 7,000. That's it. And it will be able to collect the 7,000 images. Okay. Now let's again see the dimension of your data. That is perfect dimension for us. Okay. If you want to visualize the data, you can plot it using matplotlib. Import matplotlib.pyplot as matplotlib.pyplot. So there is a little bit of spelling here. Matplotlib.pyplot, and you can plot any of the image using I am sure method. So I am going to plot, let's say 100 image. The 100th image I am going to show you. This is the image number 100. Now this is the data without mask. Okay, this is the data without mask that it is collecting. This time I will collect the data with mask. So now let me wear a mask and then I will start collecting the data. Then we'll see how it is going to work. And before that, let's save this data first. So there is a method known as np.save. In this, you have two parameters, file and the array. File name is without mask.npy. npy is the extension of my file, which is going to save 400 images in a single file in form of array. Okay, so in my local machine, I have my 400 faces. You can see in this file, I have my 400 faces in a single file in this NumPy array. There is no benefit of opening this file because it's an object, it's an array. So we do not have to open this file. Now the same thing we have to do with this algorithm. Again, I'm going to execute it. The only difference is I have weared the mask now. And let's see how it is going to work. So now it has start collecting the data of my face with mask now. Earlier, I was not having the mask, so data was of without mask. So now we will have 400 images of me with mask and without mask. Okay, I'm able to get this thing. So isn't it getting interesting for all of you? Like we are able to detect the data, collect the data by ourselves. We are not dependent on any website, Kaggle, or any other thing in this world. We are collecting data for ourselves by writing our own algorithms. So let's see how many images it has collected. And I told you that you can run this algorithm on any kind of data. Okay, let's say I was telling you that you have to create, suppose, celebrity face mask detection. And to collect the data of celebrity faces, you just need a video. Okay, run that particular for the data. Simple. So let's see, we have collected more than 300 of images and we need 400 images actually. So that's it. It has collected 400 images. And now we will do one thing. We will simply save the data as well. But first convert it into array. Okay. Now, if I show you the data with mask, so you can see this image. This time it is with mask. So I will name the file as withmask.npy. Finally, we have two files. The data is ready with mask and without mask. Data is ready with us. Now we can easily implement any algorithm in this world to perform face mask detection. You can tell me to apply logistic regression, support vector machine, decision tree, any algorithm you want. Okay, am I clear to everyone till here? So this was the most important thing according to me in this particular session, that how you are going to collect the data, how you will get the data. Although I have a data set also with me, with and without mask. I will show it to you. I already have a data, but I do not simply depend on that particular data to detect the faces. So there will be a data face mask. You can see there is a data of training and testing already divided, already split data. Now you can see this data is with mask. Okay, but this data is not actually real time. These are the fake mask. You can see the mask, the image of the mask has been like forcibly just put it on the face like this. This is the data we have. This is my real time data, but I've collected my own and I think it will give me a good accuracy also. Okay, these are the people without mask then. All right, so now we have collected the data of our own faces with and without mask. And you can simply think of the algorithm that your mobile phone uses. Whenever you open a face recognition, what it does, it collects your data of faces first. Okay, first it collect the data of your own face, then it perform face recognition kind of algorithm. Okay, now let's move forward. So finally we are good to go. And now I hope all of the participants we are having, like we have like more than 100 of participants, you all are aware of any one of the algorithm, either it is machine learning or it is deep learning. So I think I can expect from all the faculty members that are available that you might be aware of any of the algorithm in this world. Okay, I am simply expecting only this thing. If you are not, then actually in this 2 hour of session we have to be focused on any single algorithm. I cannot talk about all the algorithms. Okay, so let's do one thing now. Does the data collected via real time have impact on the performance of algorithm? Yeah, it will have the impact on the performance, because we are collecting each and everything with the line of code we are writing. So definitely, because we are not using any kind of data structures or any algorithm that will be able to perform some performance issues for us. Okay, on algorithm it will not have actually. On algorithm, okay, you are asking now on like on real time, if I'm implementing, if I'm using this data on real time data, no, it is same then. Basically it will in fact become faster because we have the data in form of array directly, and array is much more faster. Getting my point, sir? If you will apply this data on algorithms, it will be definitely faster. Now let me tell you why and how. Suppose the data I have collected, do you know the how much memory it is taking? Only 2 MB, sir. You can see we have only, it is only taking 2 MB with mask and 2 MB for without mask. So it means in 4 to 5 MB I have collected the data of face with and without mask. But if I check the memory of the faces, the data I was showing you with and without mask, now you can simply imagine how much memory they will take and how slow they will get. Getting a point? So we have this data face mask. Let's check the dimension. Let's check the memory. 140, like around 150 MB you can see. Okay. Can dataset from MFDD be used? Yeah, we can use those data as well. Okay, we can use, but it's simply basically that today's learning is like how we are going to collect the real-time data with our own algorithm. Actually, this is the main thing. Now, there are a lot of resources from where you can get the data. Like you already are aware of Kaggle and all, lot of resources we have, ImageNet. So I will recommend you, I will show you one more website. Do you know there is a search engine to search the data made by Google? Are you aware of this thing? Google has made a search engine last year. It is basically for searching the data set only. If you want to search any data set in this world, just go to this search engine. Now you can search for the data. Like you want to search for the COVID-19 data. It will show you all the links, all the websites where data is available to you. So this is one of the best platform I recommend to search for the data. I'm sharing the link with all of you. If you are not aware, then just go with this link. Okay. So let's move further then. Any other query? Any other question? Anyone? I will share the IPython notebook to all of you using GitHub. Okay. So there is a GitHub account we have, and on this GitHub, I'll share this, the code of today's session here. Okay. Later on, I will share the link. Let's not talk about this part right now. First, let's complete all the things. All right, then I think we need to move further then. Anyone else? Any other query? Any other question? Anything you would like to ask?
I think you can move ahead, sir. No questions.
Okay, then the final part is the implementation of any machine learning or deep learning algorithm. What is the accuracy of face mask detection? We'll see just. Okay, after implementing using machine learning or deep learning, we'll see like what is the accuracy of it. All right, so I think my screen share is disabled, sir. Is my screen visible now?
Yeah, it's getting, yeah, visible
Okay,
now, sir.
okay. I
Visible.
mistakenly might be clicked somewhere else. All right. So basically, we was going to see some machine learning or deep learning part. So first, I will show you one implementation with machine learning, one implementation with deep learning. So you'll have flavor of the both things. I've implemented both of them. This was one of the most important part, basically, that how you are going to collect data. Rest of the parts are kind of easy in implementation. So let's open a file here we have. So in this file, I will show you the implementation of machine learning. Then I will show you the implementation with deep learning as well. Okay, so first let me show you the machine learning implementation here. So I have implemented using simple SVM and basic PCA, that is dimensionality reduction, for reducing the 50 by 50 dimension. So if I conclude the dimension we have in data set is, it is 50 into 50 into 3, which means 7,500. Now you can imagine the dimension of our data, that is 7,500. So we need to perform some sort of the dimensional reduction or all. So I have already implemented. We'll just go through with this algorithm step by step. First step is simply importing NumPy and OpenCV. Second, I am loading with and without mask files. Okay. Third, I am checking the shape of my data. That in this case, it has 400. We have 400 or 200, doesn't matter. Then I just have reshaped my data to 200 by 7500, 200 by 7500. Okay. So is there anything you would like to ask still here? Any questions still here? I just load the data and reshape it to 200 by 7500. 7500 is 50 into 50 into 3. Okay. That will generate a two-dimensional data for you. Earlier it was four-dimensional data, you can see. But in machine learning, we do not have to use four-dimensional data. We need two-dimensional data. Okay. Now, I am doing here np.r underscore. What is r underscore? Anyone from the participants know about this thing? What is this r underscore? (50, 50, 3) is the dimension of your data, sir. 50 row, 50 column, and 3 color channel. 50 width, 50 height, and 3 color channel. Okay. So I was asking this r underscore. Anyone from the participants know what is this r underscore? Exactly. That is row wise merging. We are merging the data row wise. Row wise data has been stored. So I have combined with and without mask data in a single variable. Now the data is 400 by 7500. In our case, it will be 800 by 7500 because I have collected 400 images for each one. Clear till here, everyone? So now we have with and without mask data easily available to us. The data, the overall dimension is 400 by 7500. Now we need a Y, that is the labels. Why row wise? Because you see we have two different variables, with mask and without mask. But I need a single X. So I'm going to concatenate the data row wise. Okay. So first 200 images of the with mask and next 200 images will be of without mask. So that's why row wise data will be collected. Okay. Now the next is we have created a label 0 for the with mask and without mask. I have labeled it as 1. Is this also clear? What is this label thing? This is the Y. Okay. This is the Y. Y is 0 for with mask and 1 for without mask because this is a basic classification problem we have. All right. Now finally, I have simply imported the support vector machine here and divided the data using train test split, simple things, all the simple things using sklearn I have implemented here. Just put the data in my SVM like this. And now if I check the accuracy, it is giving me 98% accuracy here. Okay. It is giving me this 98% of accuracy. Okay. And finally, if I want to test this algorithm, I have to run this code. So let's do one thing. If I execute this code, so might be I do not have with mask and without mask. We have this file. So let's see, cannot reshape arrow theta. So we have this 400. Okay, 400. We have this 400. So I will write it as 400. Now we have 400 because, okay. So now the data is 400 by 400 and it is actually of 800. So now we have 800 number of images. Okay, 400 with mask and 400 without mask. So we need 800 labels. So the first 400 will be 0, next 400 will be 1. Now let's see what is the accuracy given by SVM and all. So this is, I think this is the easy part here. It's not the typical part here. So in training data, we have 600 images. Let's perform some dimensionality reduction and all. Then we will check the accuracy. And then we will check what is the accuracy we are getting. We are getting 97% accuracy here. Okay. So the final thing is to test the outcome. So now if I execute this code, but first I have to close the video from the Zoom meeting, I think. Yeah. So let's close this video from here. And then I need to write here 1, start the camera. Then let's see, it is saying the no mask. Okay, it is showing you the output as no mask. Now let's wear the mask. Where is my mask here? Getting my point, everyone? It is showing you now that you are wearing a mask. Okay, if I remove this mask, it say no mask. Again, I have here, it will say mask, no mask. Okay, so we are getting an accuracy of 97%. So this is a really very great thing for all of us. Okay. The important part, let me again tell you what was the important part. Important part was the collection of data, processing it. This is the easy part. SVM implementation using sklearn, I have implemented using simply sklearn. Okay. Now I will show you the same example using deep learning. I have implemented the same algorithm with deep learning TensorFlow. I will share both the examples with all of you using machine learning as well as deep learning. No difference in data processing. You will see all these steps, first few steps are exactly same. Only the difference comes here. I have imported TensorFlow and I am using here CNN, that is convolutional neural network. Okay, I am simply using convolutional neural network and just mention some filters and all. So basically the requirement is only that you must be aware of convolutional neural network. If you are not aware of CNN, that I think you need to study them first. And it is training the model, and the accuracy we are getting here is around 96% after applying deep learning in just 10 epochs. Okay, in just 10 epochs, you can see I am getting a 96% of accuracy and the loss is 0.07. And these are the graph of my accuracy and loss. And finally, if you will run the code, it will again give you the same output, mask or no mask. Okay. Is that clear to all of you? Anyone would like to ask anything here? Could we expect higher accuracy with ReLU plus 10H? Yeah, I have not experimented with different methods here. I've simply experimented with sigmoid. You can try changing these kind of things. When I will share you this code, just change these parameters. Okay. So am I clear? Everyone till here? Anyone, any other doubt? So we have successfully running this algorithm using deep learning here and machine learning as well. I'll be sharing both the things with all of you. I will share a few video links. I will share the codes, videos link and all. So basically, I have a YouTube channel here, Brain Mentors Private Limited. I will share a basic image processing link with all of you. And I guess you can also get the videos from the YouTube channel from the Vishal sir and the Arun sir. They will also share the link of this YouTube. From my side, I'm also sharing few links with all of you. Okay. So this is the, let me share the complete YouTube link for all of you. We are not the YouTubers. We are not active on YouTube that much. We are the corporate trainers and generally involved in FDPs and all. But for these kind of things, like we have for the reference part, we are started to upload some of the videos. Okay. So you can just go through with this channel and few of the videos you might find out for your purpose. You can also tell us, like, if you want us to upload some videos on a particular topic, if you want, we can also do that. Okay, so let me do last thing, share the code with all of you. Till then, we can take the queries and doubts. If you have, you can just mention your queries in the chat window.
Guys, you can write down your query in the chat section if you have any query. I can see only appreciation messages, Mr. Ravi.
Thank you, sir. What is YOLO?
Yeah, this is one question.
YOLO.
we answered.
You only look once. YOLO is actually a object detection framework that is completely trained already. You just have to use that particular framework to detect the objects from the videos and images. So like we learned today face detection, but what if I want to detect car, image and all? So I'm going to show you a few examples related to these things, because in future it will be a basic requirement for all of you. What if you want to detect some other things? Okay, so I will show you one or two things running these. Let me just open it. So I'll share the link with all of you. Sharda University FDP. So I'm creating a repository for all of you, so you can just get the code anytime you want. Except my face data, I will upload all the things. Okay, you have to collect your own face data.
Sure, sir.
Yes, sir.
Once they get the code, they can
Time a little bit.
already.
Till then, I will show you few applications that I have created. Actually, there are a lot of different applications. So one of the application is of Mask RCNN to perform the image segmentation. Okay, it's a really very great application. I would like to show it to you all. But it will take few seconds to run. Till then, I can just confirm whether the repository is created. Yes. So now, if you will go to this github.com/brain mentors, you will see one repository of Sharda University FDP. So I'm going to upload all the things here. Still running basically. As I told you, it will take few seconds to run this code.
It's okay, sir. No worries. Take your time. Okay, I will do one thing. I will upload the code after this session, because a lot of applications are running in the system right now. That's Yeah.
why it's not uh, able to upload the files. So I'm sharing the link with all of you in the chat window. You just have to go to this link after this FDP. Just after this session, I'll just upload the codes. Okay, you will be able to get these codes. Till then, anything you'd like to ask, any question? Is there any technology available right now that is better than deep learning? There are a lot of things coming related to deep learning. Actually, I'll not say that better than deep learning. Actually, they are related to deep learning. Like in deep learning, you will see reinforcement learning has been used a lot, and it is growing very fastly. So anytime you want to work with the data science part, you can either go for the reinforcement learning kind of thing. There is one more the new thing is machine translation is actually a very good thing. You can go with this also. So there are different kinds that are actually related. I will not say that they are better or they are like not better. They're actually related with this thing. Okay. Yeah, GPT-3 is also a new thing. You can just go with that also. But again, it is related. Okay, I'll not say it is again different or something. It is also related. It's not the different thing. If we use YOLO model, then what libraries we need to install? For YOLO, actually the installation is really very large and complicated. It's not easy. I will share few website link if you want, that how you can install YOLO. It require a lot of packages actually. Okay, so first let me show it to you that I was telling. This is the image segmentation plus localization kind of example you can have. It is able to detect a lot of objects so easily. You can see person, handbag. I can easily detect these kind of things. So the algorithm I have used here is the mask RCNN. Okay. So using these kind of algorithm, today we have learned only face mask, how to detect the face. But what if I want to detect the dog, the cat, the cycle, bike, car, human, handbag, anything? For that, we can go with these kind of things. Okay. Difference between MATLAB and OpenCV. Actually, MATLAB is a programming. You can see MATLAB is a programming. OpenCV is a framework. It's a package that is used with MATLAB or Python kind of programmings. Okay. MATLAB is a collection of a lot of things. Generally, a programming is. And there is one more application I would like to show to you all. But please do not laugh after looking at this application. I'm working on it actually. There is a application going on in the market recently. I don't know if you have look at these applications. The zombie, it converts your face into a zombie face. So have you, Vishal sir, you are smiling. You have seen these applications. So I have made an algorithm here to convert my face into a zombie face. So it's again the algorithm I have written using OpenCV. So let me just check whether it is running properly. Okay, so you will be able to see that it is mixing my face with a zombie face. So if this is the actual face, this is the face here, and now this is the output. Okay, so this is the face morphing actually. So my original face has been morphed with a zombie face, and now this is the final outcome. So I hope I am not looking horrible and you are not laughing. Okay, so this is a kind of application we can use. It's not, what are its application like? You are asking about which things, sir? Like, are you asking about OpenCV or what kind of thing? Achha, this zombie one, this is kind of an application just to represent how face morphing can be done using this machine learning or OpenCV. Face morphing example is this. Okay, which ID use? This ID is PyCharm. You can use PyCharm, VS Code. In today's time, VS Code is also very popular, but I will recommend for Python, go for PyCharm because it will give you a lot of packages and all. Deep fake. Deep fake is not very easy to implement. We can implement deep fake kind of things as well, but actually it requires a lot of knowledge of GAN and all that. How first, before getting to deep fake, first you should know how fake is generated. And to generate the fake and all, you should be familiar with GAN kind of things. Then you will be able to perform deep fake kind of thing as well. And it's a going on search research. In today's time, deepfake has not been like very stable. It's also in the research right now. It also based on morphology. No, I would not say it's based on morphology. Actually, what happens in deepfake kind of thing, we can generate the fake videos, we can generate the fake lip sync. So it can be related to anything, not just the morphology. Okay. Okay, or any other queries, any other questions anyone would like to ask? related to image processing, related to text processing, recommendation systems, machine learning, deep learning, big data, Hadoop, anything you would like to ask here. Biometric details in face recognition and related algorithms. Significant, like if you want to just understand the face recognition and related algorithms, actually, if I simply talk about machine learning kind of things, okay, biometric is just a name given in that particular area. What exactly happens that we learn today is similar, the thing they perform in face recognition. If you talk about the face recognition, simple, okay, how face recognition is done. To perform face recognition kind of algorithm, what they do, they simply uses this kind of a strategy that I was showing you today. They first collect the data of your face, save it, perform ML on it, train on it, and then finally test it. This is the simple kind of thing running on. Getting my point? How to connect with you? To connect with me, I think Vishal sir is the best resource person who can easily connect with me anytime. But still, I'll give you the phone number of the resource person, the contact person you can contact with. Okay. So the email ID is already given by Vishal sir in the and the phone number is also given by him in the chat window. So you can contact us anytime for any kind of query. The name of the person is, let me also write so that it will be easy for you. So the contact person will be Ekta Gupta. You can just call her and you can connect with me anytime. How can we recognize the emotions from face images? To recognize the emotion, first you need similar kind of data with different emotions. Like you need a data of smiling faces, you need data of sad faces, you need data of angry faces. Then I think you'll be able to get. And it will be better if you use CNN kind of thing, convolutional neural network kind of thing, so that they will be performing more and more in detail feature extraction from the images. That will, I think, will help you to recognize the emotions.
Thank you, Raviji. Thank
So
you
any
so
other
much.
questions, any other doubts, any other queries? Anyone would like to ask anything?
We can see the appreciation messages now.
Thank you, Dr. Mandeep.
Thank you, Raviji. Thank you so much. We can understand that how difficult it is to go live in front of the audience, but in this live mode. So thank you very much for your patience and how patiently you answered all the questions. You picked up all the questions, you didn't leave even a single question which was there in the chat window. Thank you very much for sparing your valuable time. And we will be definitely in touch with you in future also regarding the sessions with our students also, so that they can also get benefited.
Yes, sir. Sure,
But
sure.
most of the audience in this FDP was either faculty members or PhD scholars. So our students should also get benefited. So if you don't mind, we will be in touch with you regarding that also. And thank
Yes,
you
sir,
all
sure,
the
definitely.
participants for your patient listening. And you can see, sir, how many appreciation messages you are receiving. And we will share your certificate also with you very recently, just after this FTP.
Sure, sir.
Thank you very much, sir. Vishal, sir, would you like to say something? Vishal, sir, you are not audible. Vishal, sir, you are not audible, I think. Your mic is not connected.
I think there is some problem with his mic, sir.
Yeah.
Ravi sir, thank you so much for this wonderful session.
Thank you, sir.
Thank you very much, sir. Thank you. Bye-bye.
Sir, we can do one thing.
Yes, sir.
What's
For just the feedback part, they can
Yeah.
put their reviews on Google Review if they want. Like, you can share the link
Yes, sir. Yes, sir. Please.
for Brain Mentors. So I would like to request to all the participants, if you like the session and if you just want to share your feedbacks, then you can just write down on Google Review about us. So you can just search Brain Mentors on Google and just go to Google review and write down your reviews, valuable reviews, whatever you think about the session. Okay. And I've
Sure.
also mentioned the contact details. I've also shared the website link with all of you. If you want to get in touch with me anytime, you can just contact on this number.
Sure, sir. Sure. Thank you.
We will
so
also share your details to participants, sir, from our side.
Thank you. Thank you, sir.
Thank you,
very
sir.
much.
Okay. Thank you,
Bye-bye,
sir. See you
Bye-bye.
soon.
Have a great day, sir. Have a great day. Bye-bye, all the participants. So we will meet tomorrow, same time, 2 p.m. Thank you.
And also share the link of this GitHub to all of the participants so that they
definitely,
will
sir.
be able to
Definitely.
get the codes. Okay, sir.
We'll do
I'll
it, sir.
upload the
We'll do
code
it.
just in a minute.
Yeah. Thank you very much, sir.
Okay. Thank you,
Bye-bye,
sir.
sir.
Thank you, everyone. Thank you,
Bye-bye.
participants.